Okay, so let's solve this question. So this question says that calculate the number of molecules in 1.5 liters of water. The information is given that density of water is 1 gram per centimeter cube, and therefore the formula of mass of water is given, that mass of water is equal to volume into density. Now most of the student, what we will do, they will say that okay, so calculate the number of molecules, so we'll use the third formula, and 1.5 liter of water, 1.5 liters of water is given. So what we're gonna do, we're gonna use the second formula, we're gonna equate these two formulas and we'll get the answer. It's wrong. Why it's wrong? It's volume is given, it's in liter, but yeah, it's wrong because this is for the gases at standard temperature and pressure. That 22.4 liter per mole applies only to gases at standard temperature and pressure. What is STP? 0 degree Celsius and 1 atmospheric, and not to the liquids like water. Therefore, we cannot use this formula. Instead, what should we do? We should use the first formula. But sir, mass is not given. Okay, that's what we're gonna do over here. That's the point where density at this formula is gonna come into the picture. Okay, so point to be noted, very important, this formula, the liter 1 formula, is only for gases at STP, standard temperature and pressure. What is standard temperature pressure? 0 degree Celsius and 1 atmospheric pressure. Okay, 0 degree Celsius and 1 atmospheric pressure. Okay, let's dive more into it. Now how will we get to know the mass of the water? So it's very simple. Is volume given? Yes, 1.1.5 liter. What is 1.5 liter? So 1.5 liter is 1.5 liter. Okay, what is 1.5 liter? Is 1500 milliliter. Okay, 1500 milliliter. Okay, how do we get to know that milliliter? So milli is nothing but, if you go milli is nothing but 10 raised to minus 3, 10 raised to minus 3. Okay, so 10 raised to minus 3, that means if you go to 1.5 liter, so what we're gonna do, 1.5 into 10 raised to 3 into 10 raised to minus 3 liter. Okay, now 10 raised to 3 will get multiply over here. So 1.5, 1 decimal over here, 150, sorry 15, 150 and 1500. You got? That's 1.5000. Okay, so what's gonna happen now? This decimal place removes to 1, 2 and 3. Okay, which is 1500. Okay, so this will become 1500 into 10 raised to minus 3 L. What did I say? What is 10 raised to minus 3? 10 raised to minus 3 is milliliter. So we'll put, instead of 10 raised to minus 3, ml. So it is 1500 ml. Okay, what is 1500 ml? Okay, ml can also be written as cc, centimeter cube. So 1500 cc, also we can call it 1500 centimeter cube. Okay, so 1 centimeter cube is nothing but equal to 1 ml. Okay, it's just a different types of representing the units. Okay, now we have a volume in cc. Okay, why did we use the cc and not the liter? Because the density is given in cc, so we just converted this into cc. Okay, so let's use the mass of water formula. That mass of water is equal to volume. Volume is 1500 ml or cc into, what is the density? Density is gram upon cc. Okay, so 1. Okay, so what will happen? This is cc, this is gram per cc. So cc will get cancel and we'll get 1500 gram. Okay, so what is the mass of water? 1500 gram. Okay, so now we have 1500 gram. Okay, do we have the gram molecular weight of the water? No, but do we know? Yes, it's simple. What is the gram atomic weight of hydrogen? 1, because it's the first atom in the periodic table. What is the gram atomic weight of oxygen? It is 16. Okay, because it's the 16th atom in the periodic table. Correct? Okay, so how do we get to H2O? So we get H plus O. It becomes H2O. So 1 plus 1 plus 16 gives us 18. So what is gram molecular weight of water? It is 18. We have mass, we have gram molecular mass, and we know the number of molecules formula, where denominator is also a number, which is Avogadro numbers. So can we get the number of molecules in 1.5 liters of water? Yes, it's very simple. What is mass? Mass is 1500. What is a gram atomic mass? 18 is equals to number of molecules divided by 6.023 into 10 raised to 23. Okay, now number of molecules is equals to 1500 divided by 18. This will go and multiply over here, 6.023 into 10 raised to 23. Always leave this part, leave the Avogadro number aside and try to solve this fraction. Okay, so 1500 divided by 18. When you do this calculation, you will get 83.33 into 6.023 into 10 raised to 23 molecules. Okay, you can solve this very easily. It's just nothing but 18 divided by 1500. So definitely first 18 8s are 144. So we do, and it will become 600. It comes 0 over here, so 60. So 18 3s are so it's 55. So again, if 5 gonna come, so 83.0. No, sorry, it's not 55, it's 54. So again the 60 will come over here, and we'll keep on do the 3 3 3 3 3. So we do not have to write so many 3's. What do? We just sum it to the two significant numbers. Okay, so 83.33. so the final answer would be that the number of molecules in 1.5 liters of water would be 83.33 molecules.